Welcome to today's lesson on preparing pure, dry, hydrated copper sulfate crystals. Today, we're stepping into our virtual lab to put our chemistry know-how to the test with a hands-on experiment. We're about to head into our lab to explore a fascinating experiment that directly ties into the concepts we've been covering. But first, over to Sam, our lab technician, to outline what safety equipment we need.
Hi everyone, I'm Sam. Before we get started, make sure to put on your lab coat, safety goggles and gloves. Remember, safety is our top priority in any lab environment.
Let's take a moment to refresh our memory on the key concepts we've tackled so far. We began by exploring the intriguing characteristics of acids and bases, delving into their properties and how they react with one another. We then moved on to the process of forming salts through neutralisation reactions, where an acid reacts with a base to produce a salt and water. All of these foundational concepts set the stage perfectly for today's practical. We'll be applying our understanding of acids, bases and salts in a tangible way by preparing hydrated copper sulfate crystals from copper oxide. Let's get started. We're almost ready to dive into the details of our practical. But first, let's explore why this experiment is both exciting and valuable. Firstly, copper sulfate is an essential chemical used in various industries. For example, in agriculture, it serves as a powerful fungicide, while in chemistry, it is used as a reagent for various tests. By learning how to produce pure copper sulfate crystals, you gain first-hand knowledge of a process that is significant in both industrial applications and everyday life. Secondly, this experiment is a wonderful illustration of fundamental chemistry concepts we've been exploring, such as the reaction between an acid and a base. Specifically, you will see how copper oxide, a base, reacts with sulfuric acid to form copper sulfate and water. Understanding this reaction helps solidify our grasp of foundational topics in chemistry like neutralisation reactions and the concept of solubility. Finally, conducting this experiment allows you to develop essential laboratory competencies. You'll practice accurate measuring, careful observation, and safe handling of chemicals, all vital skills for anyone keen on pursuing science. Mastery of these techniques enriches your scientific expertise and builds confidence in your ability to perform more advanced experiments in the future. Together, these motivations make this experiment not just educational, but also engaging and rewarding. So let's get started and witness the fascinating changes that chemistry can bring about. Onto the practical. Let's start by gathering our materials. Sam, what do we need?
So for this practical, we need 1 mole per cubic decimeter of sulfuric acid, or H2SO4 solution, copper oxide powder, a mass balance, a measuring cylinder and 2 100 centimeter cubed beakers, a spatula and a glass rod, a Bunsen burner, a water bath container, a heat-resistant mat, a filter funnel and filter paper, a conical flask, an evaporating basin, a tripod and gauze, and finally, a lab book to keep notes.
Make sure your lab area is tidy and all your materials are within easy reach. We start by accurately measuring 5 grams of black, powdery copper oxide using a spatula and transfer it into a clean beaker. This gives us the solid reactant necessary for our chemical reaction. Next, we precisely measure out 25 centimeter cubed of clear sulfuric acid using a measuring cylinder. Once this is done, we carefully transfer the acid from the measuring cylinder into the beaker containing the copper oxide. Using a glass stirring rod, we gently mix the contents, ensuring complete interaction between the reactants. It is important to maintain a steady stirring motion to thoroughly mix the ingredients and enhance the reaction's efficiency. Next, we need to carefully set up our tripod, gauze, and Bunsen burner. Safety is important when using a Bunsen burner, so be sure to take your time setting up this apparatus. We then set up a water bath by filling a larger container halfway with water and placing it on a heat-resistant mat. Using a Bunsen burner, we gently heat the water to create a controlled and even heating environment for our reaction. We then place the beaker containing the mixture of sulfuric acid and solid copper oxide powder into this water bath. This allows for a gentle and consistent heat application to the mixture. As we heat and continuously stir the mixture, we keenly observe the gradual dissolution of the black copper oxide, which indicates that the copper oxide is reacting with the sulfuric acid. The solid copper oxide will dissolve to form a vibrant blue copper sulfate solution. Once the copper oxide has reacted and dissolved, we carefully remove the beaker from the water bath and allow the solution to cool to room temperature. This cooling step is crucial as it helps any remaining undissolved particles to settle. Next, we set up a filtration apparatus using a conical flask, funnel, and filter paper. By pouring the cooled solution through the filter, we effectively remove any residual solid impurities. The filtrate collected is a clear blue solution of copper sulfate, which we then pour into an evaporating dish to use in the crystallization process. Placing the dish on a tripod stand with a gauze mat, we gently heat it using a Bunsen burner. Throughout this process, it's essential to maintain a steady and gentle heat to facilitate the slow evaporation of the water. As the water evaporates, we begin to see the blue crystals forming, indicating successful crystallization. We continue heating until all the water has evaporated, leaving behind only hydrated copper sulfate crystals. After removing the evaporating dish from the heat, we allow it to cool completely. Finally, we leave the basin in a warm, dry place to allow full drying and crystallization. The end product of this experiment is a set of vibrant blue, hydrated copper sulfate crystals. Let's now move on to the analysis of this practical. The central reaction was as follows. Copper oxide plus sulfuric acid becomes copper sulfate plus water. Let's now analyze some of the key aspects of this experiment and understand the reasoning behind each step. You may have noted that we added 5G of copper oxide, which is a relatively large amount, and some of it remained unreacted. That is because, to obtain a pure soluble salt, it's crucial to ensure that all of the acid has reacted. The best way to do this is by adding an excess of the insoluble reactant, in our case. By doing this, you guarantee that there is more than enough of the reactant to completely react with all the acid present. This step is essential because if any acid remains unreacted, it would dissolve in the final solution and contaminate the salt you aim to purify. Therefore, even if it means having some leftover copper oxide, it ensures that every last bit of acid is converted into the desired salt. Next, we may wonder why we heated the mixture of copper oxide and sulfuric acid in a water bath, rather than directly. Heating the reaction mixture in a water bath provides controlled, gentle heat. This speeds up the reaction and ensures the safe dissolution of copper oxide into the sulfuric acid without risks like splattering or overheating. We then used a filtration process to remove any undissolved excess material from the mixture. This is necessary because any leftover unreacted copper oxide in the solution could act as an impurity and would contaminate the crystals. Hence, this step is essential for obtaining a pure copper sulfate solution. Next, we evaporated the copper sulfate to crystallize it. Gently heating the filtered copper sulfate solution in an evaporating dish allows water to evaporate slowly, encouraging the formation of well-defined crystals. This step is crucial because the rate of evaporation impacts the size and quality of the crystals. Slow, controlled evaporation leads to the development of large, pure hydrated copper sulfate crystals. Finally, once the crystals have formed, it is important to thoroughly dry them. This can be done using absorbent paper or by leaving them in a warm, dry place. Proper drying ensures that the final product is free from excess moisture, resulting in pure and dry hydrated copper sulfate crystals. This step is significant because any remaining moisture could affect the integrity and appearance of the crystals. In summary, each of these steps is essential in ensuring that we obtain pure, dry, hydrated copper sulfate crystals, starting from copper oxide. In today's lesson, we conducted a practical experiment to prepare pure, dry, hydrated copper sulfate crystals, starting from copper oxide. Through this multi-stage practical, we explored the reaction between copper oxide and sulfuric acid, highlighting the concept of neutralisation. We also delved into the process of crystallization, an essential technique for purifying compounds. This practical reinforces our understanding of key chemistry principles and hones our laboratory skills. Keep these insights in mind for your future experiments and always prioritize safety and curiosity in your studies.